Hey Tigers, today we are talking about page 24 of your notes. We are going over solving surface area problems. Our essential question today is, how can you find the surface area of a figure made up of cubes and prisms? All right guys, so we need to do a couple of quick edits on my page. I had a couple of typos here. So first thing you guys need to do is this part where it says page 24. Well, we're currently on 24, so this should actually be page 23. So go ahead and change that to 23. Cross out this extra 4 centimeters down here. It doesn't need to be there. And then go ahead and cross out this middle box. I accidentally made too many rectangles in my net. So go ahead and fix those 3 errors and then we'll get started. All right, so we're going to talk about our vocab terms first. Okay, the first one we have is cube. A cube is a rectangular prism with 6 congruent square faces or sides. Okay, guys, a cube is basically a 3D square, so the sides are all the same. Think about like a dice that you would play, you would roll. So that's a cube. Okay, it's a 3D square. Next one we have is a prism. So a prism is a shape that has 2 congruent polygon-shaped bases and other faces that are parallelograms. Okay, so a cube is specifically a prism with 6 congruent square sides. A prism could be like a rectangle or a 3D trapezoid or things like that. So a cube is a prism, but not all prisms are cubes. Okay, third vocab term here is actually a review of a term we've had in the past. Just want to make sure you guys remember. Congruent just means the same. So up here when it said prism, prism is just a 3D shape made up of rectangles and parallelograms. And congruent just means the same. So that kind of helps us understand the definition of cube. Okay, then we've got polygon. A polygon is a shape formed by 3 or more lines. So think about your basic shapes, guys. Triangles, rectangles, pentagons, hexagons, all of those different shapes, okay? It would not be a circle because a circle is made up of 1 continuous line, and can't have 2 lines because 2 lines won't ever make a shape. It'll just make 2 connected lines or 2 not connected lines. Okay, we've got 3 more. We're going to talk about base. Base is the bottom or the top of a shape. A net is a 3D shape that has been unfolded to lay flat. So we'll talk more about this in our first example. I'll give you guys an example of what that is. But it's basically like you've taken a cardboard box and you've cut it up and completely unfolded it. Okay, and then the last one we really need to know in order to be able to answer our essential question is surface area. So surface area is the sum of the areas of all the surfaces. Okay, so our previous lesson we talked about composite shapes and where we had to find different areas and add them up. This is the same type of thing. The only difference is that we're not adding together complex different shapes. We're adding up different sides of the same shape. All right, so let's go ahead and look at our first example here. So we have calculating surface area using nets. All right, so the first thing you guys are going to do, so this is a net. I've taken this shape and I've unfolded it into this, minus this mess up here. So there should only be 4 of these, not 5. Okay, so I've unfolded my shape. Then I need to calculate the areas of each shape in the net. And I need to add these areas together. All right, so guys, the first thing that I'm going to do is I'm actually going to label the different sides of my shape. So here on the top, I've got a base. Okay, there's also a base down on the bottom. You just can't see it because it's on the bottom. Okay, so that goes with, this is a base, and this is a base. Okay, then we've got our front. We also have our back, but again, you can't see it because it's in the back. So here we've got our front. Here we've got our back. And then we do have to have different sides because see how this measurement and this measurement are different? That means this side is 7 by 3 while this side is 7 by 4. So this is a different shape. So this is our side. And so we've got the right side and then the left side that we can't see. So we've got a side and a side. Okay, now that I have all of those shapes labeled, I'm going to go ahead and put their measurements on there. So here we've got 4 centimeters by 3 centimeters. So I took those measurements, so base, 4 across, 3 deep, so 4 by 3. Our front is going to be 7 by 4. So 7 by 4. Our sides are going to be 3 by 7. Okay, so this right here is going to be 3. And this right here is going to be 7. Okay, if you guys can't see that, just use this measurement because it's the same for this line and this line. Okay, I'm not going to put the measurements on these because they go with these ones over here. So once we find them over here, we can just put the same measurements on those 3. Okay, so for our base, we're going to do 3 times 4, get 12. So if this base is 12, this base is also 12. Okay, for our front, we're going to do 7 times 4, because 7 times 4, we're going to get 28. So if the front is 28, the back is also 28. And then for our side, we're going to do 7 times 3. That gives us 21. So if this side is 21, this side is also 21. Okay, so you guys can add these together kind of in 2 separate ways. So you could say, all right, there are 2 bases that are 12. Okay, right? 2 bases that are 12. 2 times 12 is 24. There are 2 sides that are 21. That gives me 42. And then there's a front and a back that are also the same, so 28. So we're going to say 2 times 28. And that gives me 56. And then you're going to add those together. So 24, 42, 56. That is going to give me 2. So that would be 9, 10, 12. So that is going to give me 122. So my surface area, so SA, surface area, is 122 centimeters squared. Because remember, guys, area, our unit label is always squared. Okay, you guys also could have just listed them all over here and said 12 plus 28 plus 21 plus 21 plus 28 plus 12. Add them all together, you still would have gotten 122. Either way, you can use multiplication and add things together, or you can just list them and add all things together. Either way, equally correct, whatever you guys want to do. So that is solving using a net. Next one we're going to talk about is using the surface area formula. Okay, so this actually requires using 2 different formulas. We have the lateral area formula and the surface area formula. The reason we need to know both of those is because part of the surface area formula includes the lateral surface area formula. Okay? So lateral surface area, the lateral area is equal to the perimeter, so P, of the bases times the height of the prism. Okay, so what we're going to do here, guys, is we've got our bases. I colored them in for you guys so you can tell which ones are the bases. So we need to find the perimeter of the base. Okay, so the perimeter is always equal to 2 times the length and 2 times the width. So we've got 2 times the length, which is 15, plus 2 times the width, which is 6. So 2 times 15 is 30. 2 times 6 is 12. So my perimeter is 42 inches. Okay, so I'm going to need to use this to help me find my lateral area. Okay, so my lateral area is my perimeter, which I just found, times the height of the prism. I'm going to scoot this up a little bit. I'm going to zoom in too. So we're going to take this perimeter and we're going to say, all right, perimeter, so 42, times the height. My height is 12. If I do 42 times 12, I get a lateral area of 504 inches squared. Remember, guys, area, units squared. Okay, perimeter, just my unit, so just inches. Once we have it be an area, so lateral area, we have units squared, so inches squared. Okay, so now that we have our lateral area, we can use that to find our surface area. So surface area is equal to the sum of the lateral area and the area of the 2 bases. So we already have our lateral area. Okay, so we already have LA. So we're going to say SA, so surface area, is equal to lateral area, which was 504, plus 2 times the area of the base. So before we can do anything else, we need to find the area of the base, all right? So to do that, we have the length, which is 15, times the width, which is 6. Okay, that gives us 90 inches squared. Okay, so I'm going to multiply 2 times 90. The reason I have 2 is because I have the bottom base, I also have the top base, so I have 2 bases. Okay, that gives me surface area is equal to 504 plus 180. All I do, add those together, I get a surface area of 684 inches squared. You gotta remember your label. So the surface area of this rectangular prism is 684 inches squared. Okay, so guys, I could have used a net and I could have found the area of this, the area of this, the area of that, the area of the front, the area of the side, the area of the side, and I could have added them all together, which is what I showed you in the first example using the net, or I can just use these formulas to do it without having to find every single shape of every single part of that solid. Okay, so guys, this is going to take a lot of steps, all right? So we're just kind of going to break it into the pieces that we need, all right? So the first thing that we're going to do is we need to find the perimeter of the bases. Okay, so the base of our triangular prism is going to be this triangle here. Okay, so the perimeter of that is going to be 30 because it's the same as the bottom here. So the perimeter is 30 plus, and then these two here, it says right here, it's 17. So we've got 17 and 17. So 2 times 17. 2 times 17 is 34. So 30 plus 34, the perimeter of our triangular base is 64 centimeters. Okay, we'll come back and use that later. Now we're going to find the perimeter of the base of our rectangular prism. So we're going to use this one right here. Okay, I know we said that the base is the top or the bottom, but you can use the front or the back. Like, doesn't always have to be the top or the bottom. Usually that's going to be the easiest one to pick, but it does not always have to be that one. And since it's easier to see the dimensions here, that's what we're going to use. False, never mind. We are actually going to use the bottom here, like I said. All right, so we're going to have 30 by 24. All right, so we've got our perimeter equals 30 and 30, so 2 times 30, plus 24 and 24, so 2 times 24. Okay, 2 times 30 is 60, 2 times 24 is 48. 60 plus 48 gives us a perimeter of 108 centimeters. So now that we have our perimeters of our bases, we can use some of our other formulas from this second example up top to find what we need. Okay, guys, I'm going to write kind of small so that I can fit all this in, so just bear with me here. So the first thing we're going to talk about is we're going to find the lateral area and the area of the bases of the rectangular prism. So I'm just going to call that R. All right, so our lateral area is always going to be our perimeter times our height. So our perimeter was 108. That's what we figured out over here. I'm sorry. Okay. And then our height here is going to be 18. So we're going to do 108 times 18. That gives us a lateral area of 1,944 centimeters squared. Okay, and I'm actually going to put a line over here, just kind of divide our space up a little bit. Next thing, since I have a little bit of space, I'm going to find the area of our base. So the area of this bottom and then the top that we can't see. So I'm going to call that the base of the rectangle. And that is going to be 30 by 24. So 30 times 24. So the base of my rectangle is going to be 720 centimeters squared. Remember, guys, areas, they are always square units. All right, so now that we have the lateral area and we have the area of the base, we can find our surface area of our rectangular prism. So we're going to have surface area is equal to the lateral area, which was 1944, plus 2 times our base. Our base was 720. And that's going to give me so I've got a surface area of, again, 1944. 2 times 720 is 1,440, which gives me a surface area of 3,384 centimeters squared. Because again, area, centimeters squared. Okay, and then I'm actually going to divide this so I can use some of this space for my triangle. All right, so for the triangular prism, we have our perimeter. Okay, I'm going to find our base. Okay, so that's going to be, again, this front part here. So we're going to call this the base of the triangle. And it's 1/2 times bottom, so 30, so the length, times the height, which the height is actually this, right? Because if we stood it up on its end, this is actually the height, okay, which was 18. So if I multiply that, hold on. Sorry, I did the wrong thing. I was getting ahead of ourselves. I was actually moving on to surface area, so I actually need us to still look at 8. It's just 8. So right here, the height. Okay, so I'm going to have the base of my triangular prism is 1/2 times, so 30 times 8 is 240. And 1/2 of 240 is going to give me a base of 120 centimeters squared. Okay. All right. So before I had you guys find the lateral area to do surface area, but I want you to look up, there's actually another option. You guys actually can just use the perimeter and the height instead of calculating out the lateral area first. So this time we're just going to put the perimeter times the height, which is the same thing as the lateral area. We're just going to use that instead of calculating lateral area in a separate step. Okay, so to find the surface area of the triangular prism, we are going to say our surface area is our perimeter. So we said that was 64 times the height of our prism. This is where I messed up on the other one, guys. So this right here, the 18, that is the height of the prism, not the height of the base. So I was jumping ahead one step. Okay, so we need to do 64 times the height here, which is the same as this. So it's 24. Okay, plus 2 times our base. Our base was 120. Okay, so our surface area. So 64 times 24 is going to give us 1,536. And 2 times 120 is going to be 240. Okay, if I add those together, I get a surface area of 1,776 centimeters squared. It's area, always going to be centimeters squared. All right, so guys, I have the surface area of my rectangular prism. I have the surface area of my triangular prism. Now I need to put them together and also take away the bases. So we've got the base of the, not even the base, it's the bottom of the triangular prism. Okay, so that's not showing, and the base of the top of this rectangular prism is not showing. Luckily for us, those are actually the same exact shape, so we just get to say 2 of them. So our overall surface area of our shape is equal to 3,384. Remember, that was our surface area of a rectangular prism, plus 1,776, surface area of our triangular prism, minus 2 times 720. 720 was our base here, and so if it's the base of the bottom, that's the same as the top, and that's the same as the bottom of this triangular prism. Okay, so that is going to give me a surface area. Okay, so if I did all of these together, I'm going to end up with 3,720 centimeters squared. Okay, guys, that was the super long process of solving for this composite solid. Okay, so as you can see, it took a lot of steps. So you guys are going to need to do a lot of steps when you solve these problems. Okay, all right, if you guys have any questions from this lesson, please make sure you put them in the Your Question column. And then I want you guys to think about this kind of challenge summary question. If the given dimensions of the prism in example 2 were doubled, will the surface area of the prism double? Explain why or why not. We'll talk about that in class.